All right, I think we've got a critical mass here. And so since we've got a packed 75 minutes, we're going to go ahead and get started. Hello and welcome to Moving Markets, the Eco and Building Electrification webinar. It's the first in our series of Levers for Change. My name is Katie Jones. I'm the Community Program and Policy Manager with the Center for Energy and Environment. We're excited to be talking about tools cities can use for decarbonization, today starting with building electrification. We hope this will be informative as well as engaging. We'll be asking questions of you throughout the 75 minutes, so stay tuned. As a quick introduction of who we are, CEE is a nonprofit organization that promotes energy efficiency to strengthen the economy while improving the environment, working with homes, businesses, and communities. We touch aspects critical to advancing energy efficiency. We run utility and community programs. We conduct cold climate energy research. We offer consulting to building owners and communities. We work with state and local policy, and we offer financial tools so people can make the upgrades that they want to their buildings. Now for our agenda. Today we'll be hearing from 4 speakers on the implementation of the eco legislation adopted last year, the status of building heating electrification technology, the air source heat pump collaborative, and the RMI Electrify cohort. And as I mentioned, we will be asking you questions throughout the webinar. If you have questions for us, please put them into the chat and throughout the presentation, and we'll get to those during the Q&A at the very end. So to start off, we've got a question for you. What drew you to this webinar? And you can select multiple.
For those of you who just joined, we've got a poll on the screen. Hi, this is Molly Janis, just helping with admin on this webinar, waiting for about 10 more folks to reply. So we'll give it a few more seconds and then I'll end the poll. Go ahead and pick an answer or multiple answers. Thank you.
All right, looks like we've got a critical mass here. And so sharing the results. Yeah, so it looks like a lot of folks are really interested in implementation from the policy of ECO Act. Want to know how to move things forward, understanding the market barriers. So great, we'll be diving into that. Then there's still some interest in understanding the city's supportive opportunities, as well as some on what are the most shovel ready. So we'll be touching on all of these things, but we'll definitely good to know in those top 2. So second question, as we're talking about building electrification, heat pump is a very important technology on that. And so we just want to get a gut check here on what are people's familiarity with air source heat pump technology. So from the very low, you have never heard the word heat pump before, to very high, you feel like an expert, you work with these every day, that type of thing.
All right, let's get those final responses in. This is Molly again, and end the poll in about 5 seconds.
All right, we've got a beautiful bell curve here. Some folks are very new to heat pumps, as well as those who've been very involved for a while, with most in the middle. So that's great to know. We'll make sure to define what heat pumps do as we go through the presentation. All right, so let's move on to our speakers. We'll be starting with Jamie Fitzke, who is our Director of Legislative Affairs. She works to protect Minnesota's deep commitment to energy efficiency and also to create and advocate for smart energy policy with Minnesota legislators. She uses her experience in program implementation, energy efficiency, and energy policy to build relationships and promote CEE's mission and impact. Jamie was deeply involved in the ECO legislation, and she continues to be involved in the rulemaking process. So I'll turn it over to you, Jamie.
Great, thank you, Katie, and really thrilled that you can all join us today for this discussion. Next slide, please. So why we're here today, the Energy Conservation and Optimization Act. So this bill passed the last day of regular session in May of 2021. So ECO is a significant rewrite of 216B 2401 and 216B 241, which contain the state's energy efficiency statutes, which is often known as the Conservation Improvement Program, or CIP for short. And I'll fully admit, I talk in letters and acronyms. So at some point, if there are questions, feel free to put it in the chat or raise your hand, and I'll do the best I can to not talk in acronyms. So to let you know, to achieve ECO becoming into law, it was many stakeholders and many years in the making. CEE, electric and gas utilities, the Department of Commerce, organized labor and clean energy organizations were among some of the numerous stakeholders that have been working on the formation of ECO since around 2015, 2016. And then we looked to introduce ECO legislation in 2019, and then it became a standalone bill in 2020. So it has been many years in the progress, but we're thrilled, and I will say also relieved that it was finally accomplished and passed into law. Next slide, please. So to provide a little bit of context, previously customer energy use programs have been siloed or non-existent. Energy efficiency has been housed under CIP, load optimization, which is demand response or load shifting. That could be considered CIP if there was energy savings, but was also typically considered separate and not involved with energy efficiency. And often for IOUs, so the investor-owned utilities, they would have to apply to have these programs through PUC dockets. So there was a separate track that they would have to use. And then efficient fuel switching was a complete and total non-starter. It was not going to be allowed here in the state. So what ECO looks to do is integrate all those components, allowing for greater innovation in utility program offerings, increasing financial savings to customers, and reducing greenhouse gas emissions. But importantly, ECO protects traditional energy efficiency programs while allowing load increasing programs through efficient fuel switching. And it was critical to CEE that energy efficiency benefits to ratepayers would not be eroded, but allow customers more options in how and when they use energy and in the technology choices they use in their homes and businesses. Next slide, please. So I'll dive into the numbers just a bit. As I mentioned before, it's a little bit administrative, but through the ECO process, CIP or ECO reorganized the CIP statutes to clearly separate sections for investor-owned utilities, and then COUs, which are known as consumer-owned utilities, or better known as the munis and co-ops. And so I'll kind of start at the bottom and work up here. The COUs, or the consumer-owned utilities, maintain an energy efficiency goal of 1.5%. Of that goal, a minimum of just under 1% has to be met through energy efficiency. The remaining 0.55 can be met through energy efficiency or efficient fuel switching. And then in addition to that, there is a cap on spending on efficient fuel switching that runs through July 1st of 2026, and that is 0.55% of gross annual retail sales can be spent on efficient fuel switching. And then looking at some previous filings, that amounts to maybe just under $6 million that could be spent annually on efficient fuel switching through the the co-ops that are members of Great River Energy. Looking at then the electric IOUs, their energy efficiency goals increased 0.25%. So it went from 1.5 to 1.75% of gross annual retail sales. Load management can be a standalone program or in combination with energy efficiency. So it provides some more filing flexibility for the utilities to include load optimization with energy efficiency. And load optimization will continue to qualify as energy efficiency when it's reducing overall energy use. One thing I do like to note is efficient fuel switching does not qualify towards the energy efficiency goal of 1.75%. And then also too, the investor-owned utilities, they have a spending cap of 0.35% of gross annual retail sales, excuse me. That runs also through July 1st of 2026. And that means about annually $12 million could be spent on efficient fuel switching programs. And that's the totality of all the investor-owned electric utilities. And then moving on to the natural gas investor-owned utilities. So they have an energy efficiency goal of 1%, and that cannot be lowered. Efficient fuel switching to an electric measure, it's a little interesting there, does qualify towards their 1% efficiency goal. Since they are going to be reducing natural gas use, they decided to let that be a qualified metric. And they have the same maximum spending cap that applies. And for the investor-owned natural gas utilities, that would be a little over $5 million annually that could be spent on efficient fuel switching. So one thing I like to note with this, a lot of numbers, but just some of the dynamics at play here is natural gas is the primary heating source in many electric service territories. So there's going to be an opportunity, I'd like to look at it that way, and that natural gas utilities and electric utilities will be able to offer efficient fuel switching programs to basically the same customers. And so that will actually allow too, in case maybe an electric utility does not offer a program, that natural gas utility program might offer an efficient fuel switching program. Next slide, please. And then probably why a lot of you are joining us today is before the utilities can offer new efficient fuel switching incentives, important policy interpretations and assumptions need to be determined. And this flowchart reflects ECO's general timeline and procedures. It's probably because I've spent most of my career in the building sector, and we concentrate on buildings at CEE. But I really look at this flowchart as setting up the blueprint, the foundation and framework, the finishing touches, and then the final product through this. And to let you know right now, the second box is kind of where we're at today. So we've had the blueprint of ECO being signed into law, and now we're kind of in that foundation and framework stage, which is the efficient fuel switching stakeholder meetings. The Department of Commerce, the Division of Energy Resources team, SIP team, is holding stakeholder meetings to take input for the important parameters that need to be determined through ECO. So this includes methodologies and inputs to calculate emissions comparisons, cost effectiveness, and baseline measures and baseline savings for efficient fuel switching. This has been a very time-intensive and technical process, and it's on a very condensed timeline. It's likely that we'll have a proposed decision issued from the Department of Commerce in late February or possibly very early March, and then a final decision issued by the department by March 15th, which is required by statute. So I would recommend that those cities with capacities to review the proposed decision to do so when it's issued, and then look to potentially consult with organizations that have been involved with the stakeholder process, and then determine if you'd like to submit comments. I think comments will be very important to have built into this process to show areas where there is common agreement, and then maybe some areas or points of concern that people can raise. And my apologies, I did not list this on the slide, but if you've got pen and paper, I can give you the docket number, and that's E,G 999/SIP-21-837. Currently, there are a few filings within that docket. Previous to efficient fuel switching, EV comments were filed into there for a particular portion of ECO that determined EV, the backout sales of EVs from gross annual retail sales. All right, back to that flow chart. So once the efficient fuel switching calculation methodologies are determined, so once we get to that middle box, then we're going to move over next step to box 4, which is the development of deemed costs and deemed savings that are used in the technical reference manual, or TRM for short. So this step is also led by the Department of Commerce and involves consultants, engineers, and utility SIP managers, as the metrics determined and established in the TRM are used in utility SIP programs, or eco programs as we might refer to them. These values in the TRM will greatly influence the efficient fuel switching program design and the type of technologies utilities will incentivize. So kind of plainly said, it's going to determine what type of building technologies will have rebates and the level of those incentives, because cost effectiveness of efficient fuel switching programs is also a key metric that's considered. So all of that said, I think it's realistic to think utilities will begin designing efficient fuel switching programs later this year, with utilities offering programs to customers potentially late 2022, but I think it's more likely for them to be established in 2023. And I'd also like to note that all parties involved are moving as quickly as possible, while also maintaining the integrity of the legislative intent and technical process that's needed. And that wraps it up for me.
Awesome. Thank you, Jamie. I love that you were just able and willing to put out that docket number just from the, the top of your head. I saw a lot of people writing.
Memorized, yes.
Great. Well, thank you for that eco primer and where we're at in the process. So now I'd like to move us on to Josh Quinnell, who's also been involved in the eco rulemaking. He's a senior engineer here at CEE. He works on grid modernization efforts, including strategic electrification, solar energy deployment optimization, and using efficiency to manage distribution system capacity. As I mentioned, he's also been involved in eco, and just as a whiz when it comes to heat pumps, I know I ask my questions of him when I have them. So I will now turn it over to Josh to talk about building heating electrification.
Thanks, Katie. Yeah, so you can see we switched topics a little bit from building electrification or decarbonization specifically into the topic of space heating electrification. So let's talk about why that's our focus right now, and we should keep it at the top of our minds. Next slide. So this is just a fact of our climate. Really, the electrification of space heating is our central objective in this climate when we consider building decarbonization. And it's really just because it's cold outside. We use more energy in our buildings to space heat them than we do all other end uses combined. So that's an important thing to reflect on, especially when we consider building decarbonization and space heating sort of in the context of these national electrification conversations. So we've got big space heating loads. We use a lot of energy, therefore we should care a lot about it. There's another really interesting aspect of this problem, and that's that with these new technologies, their performance declines essentially at cold temperatures. And what this means is that our climate tends to be, with an aside for Alaska, the most difficult climate to get these technologies to work in from an efficiency perspective. So we have high energy use plus a very demanding application. And this should really inform the way we think about building electrification in Minnesota. And again, just kind of a reminder, lots of the conversation on building electrification has a very national focus. And you'll see a lot more high priority placed on other end uses, hot water, heating, cooking, commercial cooling, and then the non-building related aspects of EVs and lawn equipment and things like that. But for us right now, space heating electrification is the prize, and that's going to be sort of the focus of at least my little spiel here, maybe more afterward. Next slide. So this all comes down to heat pump technology. I think everybody is a lot more familiar with heat pump technology probably than they imagine. Really what's new with air source heat pumps or heat pumps that we're talking about today is really just the application. These technologies are really the same thing we've been using for decades in our refrigerators and our central ACs. essentially, it's the idea that if we have, a component in one location and a component in another location, we can move refrigerant between them and move energy rather than directly combusting a fuel to make energy. We've used this principle for refrigeration for a long time. It works really well. We can cool our houses in the summer by discarding the waste heat outside in our outside condenser. The heat pump really just reverses the refrigerant flow. So instead of dumping excess heat outside, we pull it in, we scavenge it from the outside environment, and we heat our homes with it. So in practice, some heat pumps are almost direct analog to their central ACs. They really just have a valve that reverses the flow and a few extra controls to make them operate. What's made heat pumps really interesting for our climate is there's been essentially extremely rapid technology development, let's say in the last 5 years, that eclipses what we've seen in the HVAC market for a long, long time. And this is sort of due to the confluence of many different factors. The big one is that there have been a lot of disruptive technologies. So we have much better compressors now. They're combined into sealed packages that have cold climate performance improvements, digital controls, sensors, and now they're made available by manufacturing conglomerates on a pallet for very low cost. And so pretty much everybody can make a heat pump. Part of this, again, due to these technologies and this demand for them, is that there's this increasing scale. I think an important piece of context is that, the US has kind of always been on its own with respect to our preferred residential HVAC systems. And now we're essentially just adopting what has been driven by global markets, which is this convergence on sort of the mini split heating and cooling systems. Manufacture of these units overseas in Asia is 100 times greater than what we see with residential furnaces in the US. So there's lots of potential scale improvements that are leading to lower costs and rapid evolution of technology. And then sort of, it's also moved beyond us globally, is that there's lots of things happening to support heat pumps as decarbonization solutions globally. Policy supports in US cities and states, entire countries, manufacturing support abroad. This is kind of this positive feedback between all these sort of convergent factors, leading to rapid and disruptive technology improvements. And we have gained the most from that in a cold climate. I mentioned these machines are most sensitive to cold climate when it comes to their performance. And so it's maybe not too hard to understand that the confluence of these factors is sort of rapidly up the game for how well this equipment can do in our climate. And we've sort of reaped the benefits of that. We see very, very good performing heat pumps today that weren't even available five years ago. And more importantly than that, we're seeing the performance improvements from a variety of manufacturers across a variety of different kinds of products. Next slide. So there's a lot of different kind of heat pumps. This is just a list that I made to make a long list. I've broken out in a few categories for you. Technologies that are kind of ready and available in the residential market. Some products that are ready and available in the commercial market, and maybe not yet ready on a wide scale. And then there's other applications for heat pumps. So starting with residential systems, the most common systems that we find today are the so-called mini split systems. That is a system on the left. Inside we have an indoor unit, typically called a mini split cassette, and we have an outdoor unit, typically a compact outdoor unit as shown there. It distinguishes itself from the central AC units that we commonly see. These mini split systems are also available in multi-split configurations, so you can apply many different indoor cassettes and connect them to the same outdoor unit. And then we have form factors of heat pumps that are basically just resemble existing central air conditioners. There's an outdoor box. It's a square. It has a fan on top. Heat exchangers wrapped around it. Depending on the direction of refrigerant flow, it's either heating or cooling. We also have dual fuel systems. So we can actually combine a heat pump with a furnace, just like we would an air conditioner. And now you have a system that can do cooling, and then it can do heating either with the heat pump or with the existing heating system. In most cases, a natural gas furnace, but that could also be a propane furnace. We also have air to water heat pumps. So all these examples I gave right now are typically transfer air to air. So there's a forced air inside your building that's moving around energy, and then it's scavenging air with an outside unit that gets its air from the environment. If we instead replace the indoor unit with a water loop, we can now heat a house that has a hydronic distribution system where it gets boiler heat. So heat pumps work in those applications too. And then sort of another very related technology is the ground source heat pump. Still fundamentally a heat pump, but instead of having an outdoor unit that scavenges or dumps heat to the air, it essentially has a ground loop, and it dumps or scavenges heat from the ground. That's very nice because that tends to have very constant temperatures, which gives us high efficiency. The downside is it's very expensive to drill. So although ground source heat pumps have been around a long time, we haven't seen much traction because of their cost. On the commercial side, it's basically the same set of technologies, but they have different names. So instead of multi-split heat pumps in the residential space, they call them VRF heat pumps in the commercial space. That stands for variable refrigerant flow, but it generally is a bunch of indoor units that are connected to an outdoor unit so that they can have zoning in that building. Again, you could apply ground source heat pump technology in a commercial setting. Other common heating systems that are in commercial buildings are PTACs. So these are I commonly refer to them as the hotel unit. It's basically the heating or cooling system that sits under the window in a hotel room. And then RTUs, they're the dominant heating system in commercial buildings. Both PTAC and RTUs have started to see the introduction of heat pump products, but they're not really out there yet. They haven't really been tested at a large scale, and there hasn't really been a big demand for them yet. I'll talk about that in a minute. And then heat pumps work in all sorts of other applications. They can work at a higher temperature for industrial processes. Of course, another important building electrification technology is the heat pump water heater. And now we're starting to see heat pumps in electric vehicles due to the efficiency promises they bring there. Next slide. So heat pump technologies today are pretty concentrated in the residential sector. That's just where we've seen movement first, more or less. And there's kind of two big application categories for heat pumps in residential construction. First is using the mini split. So mini splits are essentially usually smaller systems. They work really well to augment existing systems. They can entirely replace systems in new construction. They can also replace lots of what we see in multifamily construction for heating and cooling systems. But in single homes, there's a lot of various applications too. They're very good for home additions, remodels, ADUs, garages. Traditionally, our approach in these situations is to try to extend an existing ducted HVAC system, and that never really works very well. But we live sort of with that trade-off. Usually retrofitting an HVAC system for a space redevelopment is just prohibitively expensive. Mini splits give us an opportunity to sort of bring in high efficiency and do a better job, frankly. When we also see probably the biggest application right now is the introduction of sort of the central heat pumps and their ability to essentially be a box-in replacement for air conditioners or air conditioner furnace packages in our single family homes. One option is to go all electric, replacing the furnace with a heat pump and potentially some electric resistance backup, depending on the specifics of the building. And the other option, which is also very viable, is to replace the central AC with a heat pump and keep the furnace, or also include a furnace in the heat pump swap in. This gives you the heat pump that you can now sort of balance against your existing furnace and use it in a way that suits your particular application. These things they're accelerating very rapidly, and it seems like there's no end to the growth, at least in the near term. On the commercial sector, things are very far behind. There's fewer application options available today. There just seems to be less demand, less overall excitement about heat pumps in these applications. I will say that there's no real technical barriers here. It's just a matter of essentially changing products to meet these applications. And I think that means that when the commercial sector is ready, or when there is potentially policy support or some source of demand, that we'll see these technologies developed extremely rapidly, and they'll essentially learn from the last 5 or 10 years of what we've seen in the residential market, and they'll be able to bring new products to market very quickly at competitive pricing. So it's not really ready yet, but I feel like it's inevitable, and it will be here very shortly on the commercial side. Next slide. So just to give some pictures to what I spoke about. So mini split applications, they are kind of varied, and they can go in everywhere. Upper left corner is mini splits being adopted in an existing multifamily building. Here they're essentially conveniently locating 3 outside units right next to each other high on a wall. They're all feeding new replacement heating, cooling systems for each of those multifamily units. The upper right-hand corner is a relatively small electrically heated house. This is a house that could be, at relatively low cost, be completely retrofitted with a mini split or a multi-split system to do all of the heating and provide cooling to a house that previously either had window units or no cooling at all. The bottom left is a retrofit, a remodel application. It built out another roof off the back of the house. Changing the HVAC system was a possibility, but prohibitively expensive. So they put in a mini split. The house actually, this addition is communicates well with the rest of the space. So that mini split not only serves that space, but offloads cooling and heating load from the primary less efficient system. And then a big application that we have been thinking about lately is the introduction of cooling systems to houses that haven't had cooling systems and have older hydronic heated systems. Mini splits are a great option here because they give cooling and they can also offset boiler heat, particularly in the shoulder seasons. So mini splits are kind of a jack of all trades, and they can go in a lot of different applications and meet a lot of different use cases. And that technology is all ready to go today. Next slide. But most of us in Minnesota live in single family houses. And of those, most of us have natural gas furnaces and central air conditioners. So we have the infrastructure to do these sort of whole home systems. In the past, we've called them central ACs, and the opportunity for heat pumps is essentially box in replacements for these units with heat pumps. There's kind of one important application, which is simply starting with replacing old ACs with heat pumps. We're currently doing a number of projects to try to assess, which is the best kind of system to drop in this case, in terms of the savings and the environmental benefits. But it's a really promising opportunity because there's really no requirements. And you have the option of either replacing your furnace if it's time, or keeping your existing furnace. And then since you have two heating systems, by the way, that's also a fantastic thing to have. If one breaks, you have another one on hand. That's usually not the case. But you have the two heating systems, and depending on your goals, you can operate them as you wish. So you can operate them based on your cost sensitivity. So if your goal is to overall reduce your costs of heating and cooling, you have that option. If you're doing it for environmental reasons, you can aggressively operate the heat pump and lower emissions. And you can also choose something that's right for you to balance sort of your environmental concerns with your overall operating costs. So again, there's a lot of flexibility we have with these current residential heat pump applications, and we're kind of just feeling out which applications are best, or which heat pump use cases are best for which applications. But a lot of them are ready to go today, especially in the residential space. Next slide. So there's a lot going on right now. There's also a lot of stuff that we are still working on, collectively called the barriers of air source heat pumps. I can kind of sum them up really quickly. There is the existing building envelope. There's the cost associated with installing and operating the equipment, and then there's sort of the general familiarity and acceptance. So building envelopes, this is sort of the building shell. This is all the external surfaces on a building. We don't have very good building shells, and consequently, we use a lot of energy to heat our homes. The availability of very large natural gas furnaces and very low natural gas costs has somewhat insulated us from that reality. But the bottom line is air source heat pumps are a lot more specific, and they require us to do more due diligence in understanding what our building's heating loads are and what the capacity of the equipment we're installing can do. And I think what we'll find is this is going to play out a lot more in detail. It's going to be this continual give and take between sort of the quality of our building envelope and the availability of air source heat pump equipment. Costs are sort of an issue right now. There's lots of applications where heat pumps are cost effective today. They're generally cost effective if you've got older electric heating technologies or propane heating technologies. However, as mentioned, most of us heat with natural gas. Natural gas is very cheap. Heating via a heat pump with electricity is generally more expensive than meeting that same load with natural gas. I will note that this changes constantly because fuel prices are actually quite volatile. Most people have probably noticed that their current natural gas prices are very high. But that will change sometimes in favor of or against natural gas. And we're also seeing continually improving performance out of these heat pump systems that will sort of start to erode this cost benefit of natural gas. But in the near term, these hybrid solutions are a really great solution. They basically allow us cheap natural gas when it's cheaper to use natural gas. They allow either mini splits or dual fuel systems to take on that heating load when we can do it cost effectively with heat pump equipment. So they're a great introduction to heat pumps in the marketplace. And that leads to this third barrier, which is familiar and acceptance. They're still very new. So there's still not a lot of heat pumps out there, maybe 1 or 2% of total market share. And one of the major barriers of new technology is people are not familiar with it. The people that install it, they haven't quite gotten confident installing it, and they don't really want to guarantee it. And so starting to recognize these easier, lower hanging fruit applications is a really good way to introduce the market to this technology, get consumers to accept it, get used to it, understand that it works for them in their situations, as well as sort of takes care of some of the concerns of all the folks that are installing and maintaining these systems. We just need the experience with the technology so that it can, reach high market share. Advice for cities on building electrification. So again, I want to reiterate that space heating is the most important part of building decarbonization here in Minnesota, and we shouldn't lose sight of that fact. We also shouldn't neglect the other opportunities, but this is what we must succeed at if this whole plan is to work. On top of that, I mentioned that the building envelopes are a cause for concern with respect to rapid heat pump adoption. And I think a simpler way to say that is it's not all homes are yet air source heat pump ready. But there's a lot of things we can do, particularly in our cities, to sort of figure out which homes are ready, figure out which homes are not ready, and try to improve them. And that's one of the big tools available to us are energy audits. A quick energy audit essentially can tell us whether a home is air source heat pump ready or not. It can also identify some things we can do to get these homes to readiness. The standard successful endeavor is weatherization. Weatherization work is cost effective, typically more cost effective, and has more benefits than air source heat pumps. So it's a great first step in considering the electrification of building heating. And we should even start thinking longer term beyond simple weatherization steps. There's a lot of things we can do to our houses and our commercial buildings too, to essentially lower their heating loads even further, make it even easier to adopt air source heat pumps in the future. And that's considering larger building upgrades such as exterior insulation, significantly improve windows, and start to think about concepts such as passive house retrofits and deep energy retrofits as a way to improve our building stock. And the last tip is this stuff is changing very, very fast. I'm focused on it and I can't really even keep up with it. So that's just sort of a bit of advice in that what we're saying right now is true right now. Expect it to evolve in 6 months or 12 months and be completely different. And I think the optimistic way to understand that is that, what we talk about as limitations today are really the things that we're working on, and they will represent sort of the next wave of opportunities next year or the year after that. I think that's it, right?
Yes, thank you so much, Josh. And this actually leads us into our next poll, which has to do with what communities can do and what they're interested in doing. So got a poll coming up. I'm curious, how does your community currently support heating electrification efforts? And this is not at all for any shaming or anything like that, or for particular prize giving, but we just want to know, what is the state of how cities have been engaging on electrification? Because as Josh was saying, these technologies are coming. There are great applications in the residential sector, commercial sector still coming, and where can cities plug in is what we want to help cities to do.
Hey everybody, this is Molly, just encouraging you to fill out the poll. We will leave it open for about 10 more seconds. Go ahead and enter your response.
All right. I think based on the number of cities that I saw register, we've probably got all of them represented here. So Molly, we can close the poll. All right, so it seems like there is, people who just have, or cities that haven't supported to date, but there is quite a lot of just general support and maybe not any resources that have been allocated, and some that are providing some education, and one that, or two that are also providing some financial resources. So kind of on the early stages of heating electrification support. So this is great to know. All right, let's move on. And we're going to jump into kind of more of the how to get buildings electrified with heat pumps. So next up, we have Robbie Vandergaan. Robbie manages the Minnesota Air Source Heat Pump Collaborative and consults on research, planning, and engagement projects with utility partners in North America. So he'll be talking about the collaborative and roles that cities can play to further heat pump adoption. So take it away, Robbie.
All right, thanks, Katie. Josh covered a great background and setup for what I hope to talk to you today. And one thing Josh mentioned is the kind of the why. So that's around energy savings and carbon savings over the lifetime of equipment. And so what the collaborative is focused on is addressing some of these barriers that are on this slide here. And some of them are short-term barriers, such as product availability after hopefully COVID is winding down. We expect to see some of these things fade away. Others are aspects that we're focusing on with the Air Source Heat Pump Collaborative, like contractor availability, for example, and some of this nuance around these application types that Josh touched on. So on the next slide, it shows the Minnesota Air Source Heat Pump Collaborative utility members. And the collaborative was started out of a need for these folks to try and accelerate the air source heat pump market a bit faster than what was being observed. And our funders, as you can see, cover most of the state. And so we are able to work across different boundaries to provide this general information. And I also wanted to mention, we also do some training and provide resources to Excel Energy, which aren't shown here, but wanted to mention. And then we're also collaborating nationally to provide best practices that other organizations like the Northwest Energy Efficiency Alliance and then the Northeast Energy Efficiency Partnership have identified. And so on the next slide, we see our Air Source Heat Pump Collaborative goals, which are to maximize savings through utility programs, to coordinate among Minnesota utilities, support the trade industry, and accelerate a technology that plays an important role in decarbonizing Minnesota's economy. And giving a program overview on the next slide, without trying to digest all of this information in just a short amount of time, I can just mention that we focus on 5 key areas with our program, and that's technical guidance and installation quality, keeping market partners in our communication loop, providing training and support to installers, providing market partners periodic market reports, and then also coordinating with utility programs to advance the market. And one of the things we're proud of is that CEE has done a number of research studies on air source heat pump technology, and Josh and other fellow researchers have really dove in headfirst into this field. And so we got started with our first project in 2015, and then that was followed up by other projects, some of which are currently underway. And those include studying the applications for heat pumps in multifamily buildings, understanding how to optimize air source heat pumps in single family homes, and examining how direct air conditioner replacements with no changes to furnaces can be applied to homes with natural gas heating. And to give a brief summary, from our earlier research, we found that there are significant savings opportunities right now in some specific market segments. And those include homes with propane heating, and then also homes heated by either electric resistance or electric furnaces. And those savings are significant in terms of homeowner energy cost savings for operating their heating equipment. That can range from 30 to 55%, which is what we found through observing these homes directly. And then there's also emission savings opportunities, and those will continue to grow as the utility mixes continue to decarbonize as resources are shifted away from coal and other carbon intensive resources. And also you can see that we were able to monitor that the equipment was able to perform really well in our cold climate. So in these homes that we monitored, we found they could put out heat as low as -20 and do so efficiently at -13. And I think that some people on the call have heat pumps currently providing heat. I won't point anybody out, but I just wanted to mention that they're warm and comfy right now too. So on this slide, we can see, this is a chart showing the expected source of where energy savings will be acquired through Minnesota gas and electric utilities through a project CEE led, the 2018 Energy Efficiency Potential Study that we did for the Department of Commerce. And on the left shows all sectors where the energy savings were attributed to, and we can see that that's primarily going to lighting savings. But as we look to this decade that we're currently in, we expect that those opportunities will be fading, so to speak, and we'll be needing to find these savings in other sectors. So one thing that we found is that the space heating portion of a home, as Josh mentioned, is where we can really hone in to achieve more savings. And lighting will be a really small portion because of standards changes. And many of you on the call right now probably have LEDs in their homes, for example. So we won't be able to reap those savings any longer. And on the next slide, if we break out that 35% figure a little further, we can see that air source heat pumps are one of the main channels that we expect to achieve these savings, with the largest energy saving opportunity being those homes with electric resistance. But other applications, which I'll dive into a little bit here, will also be possible. And on the next slide, we have a chart of, we basically broke out Minnesota's building stock into these different segments, and Josh touched on some of the technology that might be appropriate for these different homes. And we can also see the market size of these homes. So looking at it a different way, on the next slide is more of a visual that might speak a little better than a table. And homes with air conditioners and natural gas furnaces encompass about 1.2 million homes. And so that's the largest opportunity for heat pumps as AC replacements. And for homes with natural gas heating to capture savings, we recommend considering a standard air source heat pump, at the very least, sized to the cooling load as an alternative to AC. So we're trying to avoid folks buying air conditioners at this point in time. And this hybrid approach with the existing furnace can also potentially reduce short cycling, which is when a furnace is turning on and off a lot because it may be oversized to the heating load in these shoulder seasons. So there are multiple different value streams that a heat pump on the shoulder seasons can offer. And there will be more on this topic that will be released as part of that research project I mentioned earlier. And on the next slide, I just wanted to hone in a little bit more and just reiterate that the highest energy savings opportunities are achieved by replacing electric heat. So that's really where we're focusing primarily with our program. However, looking at the audience list, those opportunities are mostly in rural parts of our state, so maybe less applicable for this group. And then also, I did want to mention that propane segment again. That's about 250,000 homes as well. So in terms of where the market's at now, On the next slide, we have been collecting utility rebate data for those 5 member utilities that I mentioned at the top of the presentation. So this doesn't include Xcel Energy, but we can see that our rebate activity really jumped between 2019 and 2020. It more than doubled. And this data goes through the third quarter of 2021. And we can see that the amount of rebates in 2021 was about 3/4 of the way to 2020. So the rapid growth seems to have leveled off, but we think that is probably temporary. There's been a lot of supply chain constraints as manufacturers have really focused in on their high volume products. So they're making things like air conditioners more readily available than heat pumps. So we are working with the distributor partners with our program to try and get ahead of the market as eco is coming more towards fruition. So we hope to continue to see this grow, but we're still pleased to see that it hasn't declined, that it's continuing about level between 2020 and 2021. And in terms of resources we offer, there's a number of things on our website. I think there was one question about how to stay up to date with some of this changing technology. And we do have a newsletter that we will publish the CEE research as well as other contractor resources. So if there are different products coming out on the market, that could be a way to learn more information. We also have free training modules that anyone can register to sign up for and watch, that covers an overview of air source heat pumps, as well as some of the nitty-gritty around best practices for installations. And then we also recently just launched a preferred contractor network, which is a lead generation tool. And if you could jump to the next slide, please. That's a lead generation tool that we hope to list the companies that are excelling at this technology right now with the products that are already ready for the market. So we know that these are going on right now. Folks are getting these installed, and we want to be able to highlight these contractors that are doing good work. So we have a number of companies that have signed up. We just launched this in December of last year, and we already have about 15 that are at some point in our pipeline for this new network that we'll be releasing. And then what we hope to do next is have a list so we can make it easier for homeowners to find these contractors, because that's one of the barriers to adoption is where to find someone that can do the installation itself. And next, I want to dive into an example of some of the nuance. This is another thing we're trying to communicate because it really makes a difference on what the equipment is, what the fuel type is, and how it is operated. So on this slide, on the left is a conventional furnace and AC. So that's maybe the baseline consideration. And in the center would be a dual fuel system. So that's that system Josh mentioned that would have a furnace backup, and then an air source heat pump could cover 2 different temperatures shown on the bottom part as a switchover temperature. And the operating costs are shown by the size of the bar. On the right is an all-electric solution, and depending on gas costs, that can be typically more expensive. So these are using averages for Great River Energy Co-ops. We're currently doing some modeling for Xcel Energy, and we'll be making this tool available on our website. But these results are typical, even though there are some variations between different utility costs. The results generally show that the all-electric solution in natural gas territory is usually more expensive, but a dual fuel option could be competitive. And what's interesting is that if we look at maybe a 35-degree switchover scenario, depending on the equipment, it might only cost an incremental amount annually to go to a moderate switchover temperature at 35 or 25, and the consumer won't be paying a lot more, but they'll be offsetting a lot more of that furnace use than they would have been otherwise if they had chosen an air conditioner. And on the next slide, I just wanted to also mention that many utilities offer dual fuel rates. Electric utilities offer dual fuel electric rates, and those can make the cost proposition shift a little bit more. And you can see here that that in this case, with GRE's dual fuel electric rates, that could allow someone to choose something like a switchover temperature of 15 degrees. So going a little colder, offsetting a little bit more energy use from the furnace. And I also wanted to mention that we're on the next slide, communicating this information to contractors across the state. And we've done a number of those presentations last year, and we have some scheduled. I'll actually be going to Rochester, so we'll have a third dot on the map after tomorrow. And I'm running out of time, so I'll keep moving quickly. We also have some homeowner resources available, so people wanting to learn more can get some of these pieces of information. Our FAQ right now is a good place to start. It has a list of contractors that we've worked with through our research projects, as well as have other positive relationships with. And we offer a number of buying guides. We just launched a blog, and then coming soon is that preferred contractor network that I mentioned. And lastly, how cities can get involved. I really highly recommend exploring our resources. You're welcome to get in touch with us directly if you have questions. Signing up for that newsletter is a great way to keep up to date with any changes. And we also are happy to partner with you if you are looking to put any media posts out there. We have a marketing team at CEE that we work with on the Air Source Heat Pump Collaborative, and we'd be happy to partner with you. And I think that is about it for me.
Awesome. Thank you so much, Robbie. A lot of rich sources of resources for cities out there, especially on the Heat Pump Collaborative website. So I want to move over to let Jen Hassebrook talk about Minnesota's participation in the RMI Electrify cohort. So Jen, are you there?
I am.
Excellent. Take it away.
All right. Thanks, Katie. So I just wanted to give everybody a brief update today on a project a number of us local cities are working on right now called the Electrify cohort. And that's something that is put together by the American Cities Climate Challenge and RMI, which many of you probably know as the Rocky Mountain Institute. They're a nonprofit that works on decarbonizing the global energy system. They're offering this Electrify community cohort as part of their outreach work in 2022 to help cities across the country increase their building electrification. And the model of this cohort is based on some campaigns that they've done similarly around residential solar applications. So the main goal of the cohort is to help cities accelerate heat pump adoption for either space or water heating specifically by creating Electrify campaigns in each community that have three kind of main goals. Increasing community awareness by working directly with local frontline organizations to learn about local barriers, particularly for those in underserved communities, to develop an educational campaign. The second is to train contractors on heat pump specifics to increase their confidence in the technology and their application in this climate. And then lastly, to help reduce upfront cost barriers through either an RFP or contractor verification process and the development of financing tools and incentives. So all of the cities that are participating in the cohort, along with their community and technical partners, went through an application process to join the cohort. So locally, the cities of Minneapolis, Edina, St. Louis Park, and Eden Prairie are all participating in this cohort together, along with representatives from Minnesota Renewable Now, Citizens Utility Board, and our host today, CEE. We're joined in this cohort by cities and counties from across the country. In the Midwest, Ann Arbor, Grand Rapids, Cincinnati are participating. And there's also clusters of communities or cities around Seattle, Denver, and the Washington, D.C. area. So for us, thinking about this campaign, it made a lot of sense for our cities to work together as we all have strong goals around building electrification in our climate action plans. But at this point, nobody had really moved into program development yet. And as all of you are probably aware, we've all been kind of increasingly working together on our climate goals. So this kind of felt like a natural extension of that work. And just so you get kind of a sense of the scale of the goals that we have, for example, here in Eden Prairie, we have a goal that 17% of residential buildings that are now served by natural gas have switched over to electric by 2030 and 55% by 2040. And to even hit that 2030 goal, we're talking about just shy of 550 homes per year switching over. So it's certainly a big ask and a big push. And we have a lot of work to do to educate the public, as we kind of talked about through this whole presentation. So a few of the reasons all of our cities decided to join this cohort process was just building a successful education campaign. It takes a lot of time and expertise, and we thought by doing this together with expert guidance, it just would make our program stronger. We also thought there was a lot of value in having the same campaign available in all of our communities in terms of helping spread public awareness about heat pumps and sharing resources. And we just thought it was a good opportunity to learn from our peers and experts in other parts of the country that maybe already have similar programs and just kind of get that national perspective as well. And then lastly, our other thought was we knew that the changes with the ECO Act and the rebates around electrification were coming, and sort of the timing on this works out well, that hopefully we'll be ready to launch these programs right around the same time we have that utility support in terms of rebates and such. So just kind of a summary on that. We actually just had our first meeting in the last week or so. It's basically a year-long process, so we'll have more to share about that in the future, but just kind of an update on one of the things the cities are looking at in terms of heat pump adoption.
Yeah, thanks so much, Jen, to give like a city perspective on why you're working together on this. And I think it is just really critical. Like, as you were mentioning, our goals are big, and I think we can do more together. And, our purpose today was really to make sure that a number of cities like we are getting this kind of background of where is the technology at, what is the best application. And so hopefully it'll be helpful as the cohort continues. So those are all of our speakers, and I know there were a number of questions that came through the chat, so I'm going to stop sharing for the time being and kind of go through our questions as we have in our last 12 minutes together. So to start, and these are for our panelists, what other costs does a property owner need to consider besides the cost of the unit in operation? Electrical panel, changes to ducting, maybe that's best for Josh.
I mean, that's a very tough question. A yes to all of the above. I think what we're doing right now, we're in process of trying to identify essentially the lowest hanging fruit. So all the applications where those complications don't have to be dealt with yet. That's why we're kind of moving toward mini split solutions and hybrid solutions, as they give us a way to introduce this technology without having to sort out the hardest aspects of the problem. And ideally, this approach gives us time to sort that all out and make that part of the process.
Awesome. So another kind of, it touches on cost comparison, but how would you compare mini splits for cooling to an AC window unit in terms of upfront costs, operational costs, and the ability to provide a comfortable environment? Probably again for Josh.
Okay, well, I'll say things. That's also a very hard question. The hardest part of the question is typically the mini split you install would serve a different load than a window unit. So it's typically mini split versus a couple window units. There are some overlaps. So in the smaller part of the mini split capacity range and the larger part of the window split range, you might find products that are pretty similar in capabilities and the load they serve. I think there you'll see a pretty good price convergence in equipment. Actually, the issue right now is probably the cost to install those mini splits hasn't come down yet. We're still waiting for that market to essentially become efficient, in that there are lots of contractors who know how to install those systems relatively easily. I don't know. I don't have anything else to say about that other than it's a tough question.
So you're saying it's more on the load that decision is made on?
Yes. How's that for confidence?
Okay. Well, Carmen, if you continue to have thoughts on that, you please, add to the chat, or we can follow up later. There's a question about retrofitting multifamily buildings with mini splits. Is there a maximum number of units that is feasible? So number of like systems that can be put on a multifamily building?
Oh, no.
No maximum.
Probably no limit. At least the limits are going to be below the number of systems you need to heat and cool that building. I do know that there are some issues associated with putting mini splits on buildings that have either historic designations or special zoning designations, so they have to look a certain way. And in that case, it's maybe a little bit complicated to run chases and things like that, or actually put mini splits on the outsides of units. That's sort of a case-by-case basis, may be barriers in some applications. Those are the kinds of barriers that I think we can work on. We just need creative solutions.
Sounds good. Another technical question, a lot of technical questions right now. Can you describe how envelopes represent an opportunity for current efficiency programs to enable future heat pump installations and fuel switching programs?
Oh my gosh, I can talk about that for all time. So I've actually been doing a lot of work on envelopes recently, and we can maybe point you to a webinar we recently did on the conclusion of a card project. That final report is forthcoming. Essentially what it found with respect to it studied exclusively single family construction. We found that almost all homes, in excess of 90%, could still use some basic take that back. All homes built before 1990 could use at least one basic weatherization measure. Most homes still need 2 or 3 measures. These range from attic insulation, air sealing work, wall insulation, rim joist insulation, these kinds of things. So there's a tremendous appetite out there, potential appetite for existing weatherization work to just scale much to a larger scale than it has been to date. So that's the opportunity that's here and now, is to just simply expand weatherization informed by energy audits like CEE offers, to just kind of fix these glaring issues in our envelopes. And then we can get to the point where our envelopes sort of have this universal foundation of okay performance, and sort of then advance into more sophisticated retrofits that I guess bring our building stock beyond sort of a minimum performance standard, but maybe a performance standard that is commensurate with our climate needs.
Sounds good. Another technical question: do we, Midwest cold climates, understand the necessary minimum specifications for heat pumps to be successful in this area? So do we adopt NEEP specs or something specific to the Midwest?
That's a really good question. Others might have some things to say, but I think NEEP is for the applications we're considering right now, which is essentially mini splits and hybrid solutions. NEEP gives us everything we need to know about heat pumps. I think what we'd like to see as we move toward heat pumps that are going to be the primary and only heating system is to get performance data and specifications at even lower outside air temperatures. So if I'm not mistaken, NEEP goes down to 5 degrees now. Here in the metro area, it would be very nice to have performance data from manufacturers at -5 or -10. And then in outstate Minnesota, we'd really like to see -20. This is the data that we're going to need if we want to size these systems to meet full Minnesota heating loads. But for the applications that we have right now that we're focusing on. The NEAP is a phenomenal resource, and I can't understate that.
And maybe I could piggyback on what you said, Josh, because I wanted to clarify something I said earlier, is that folks that are in natural gas territory might consider a single stage heat pump, which is not cold climate rated, but those systems will have some caveats. So they don't operate as well as a cold climate product would, with a couple different ways. So they're not able to, for example, a user would be limited on how low they could operate that system if, for example, right now with natural gas costs being really expensive, someone with a single stage or a conventional heat pump is not going to be able to reap those savings. And then also some of the performance, like the modulation and ability to dehumidify better, that would be offered by a cold climate product versus a single stage or conventional unit. And NEAP, I'll follow on Molly's list. NEAP has a great list that's publicly available. So you can look up if a unit is cold climate rated. And even though there are some improvements needed, it still does have a lot of great information and some basic requirements that will work well in our climate.
Awesome. And Robbie, there was also a follow-up to that question. Is it up to the contractors to know if this information and be able to recommend the systems to the homeowners? You know, is it on the contractor basically?
So a contractor in our preferred contractor network would have that information on hand because that's part of our training curriculum.
Awesome. Well, we have just 3 minutes left here, and I have just a quick little poll that I'd like to post up here. If I can find how to share my screen again. Oh, actually, so we've got this poll of how would you like to support future efforts in terms of electrification? So if you wouldn't mind answering that question. So this is kind of in a follow-up to the one we had done, which was what is the current state? What would you like to be doing? All right, I think we've hit the majority of cities that are represented. So if you want to go ahead and close that poll, Molly. So a lot of you want to provide education to homeowners. So like we said, we've got a lot of resources on the Air Source Heat Pump Collaborative website. So we'll make sure to send that out as a follow-up in an email as well. So it's good to know too that someone would like to provide training to professionals. Again, we can partner as the Air Source Heat Pump Collaborative with cities on that and then help you think through some financial resources as well. Yeah, so last but not least, a kind of fun question. If you wouldn't mind putting in the chat in this last minute, name one thing from this webinar that was new or interesting to you. As you're doing that, I'm going to just share that we have 2 other planned webinars in this Levers for Change webinar series. On the 23rd, we'll be talking about codes, so driving efficiency in new construction and some of the legislative as well as regulatory things happening there. And then in March, I don't quite have a date yet, but we'll be having one on green careers, so how to advance equity and green jobs. So. Thank you for sharing everything, all your ideas and the things that you've learned in the chat. I want to be respectful of time. It is now 1:15. So just thank you for joining us. If you have any follow-up questions, please don't hesitate to reach out. My email is there.